So in this lesson, we are looking at scientific notations and their unit multipliers. Now in physics, we make a lot of measurements, sometimes very big measurements. Example is when you are measuring the speed of light, 300 million meter per second. Sometimes we get very short values. For instance, the radius of the hydrogen atom. Sometimes the values get extremely large, bigger than even the speed of light. Example is stellar distances. And other times the measurement gets very small. As scientists, reporting these bigger values or extremely small values make computation difficult, make communication of the values also difficult. So an approach is adopted. So scientists adopted a way to summarize these values so that it can be communicated easily, it can be recorded easily, and then it can be understood easily. This method adopted to achieve this truncation or this simplification is what we refer to as scientific notation. And scientific notation is always of the form a times 10 exponent n. Now, scientific notation is of two parts. Now, the first part is called the coefficient, and then the second part is a power of 10. And the coefficient is always a number, either 1, 2, 3, 4, 5, 6, up to 9. It has to be between 0 and 10 at all times, irrespective of the value given to you. The value of this first number, which we call coefficient, should always fall within this particular range. The second part, we said the power of 10 is carrying an integer, is carrying a power n, which is an integer. The integer can be positive and it can be negative. Now, when n is positive, it means that our coefficient is being multiplied by a multiple of 10. So example, if we have 2 times 10 exponent 2, it means that 2 is being multiplied by a multiple of 10, which is 100. The 2 represents basically literally the number of zeros that are accompanying 1. Just have that in mind. The number of zeros that are accompanying 1 is mostly represented by the power 2. But when n is negative, it means that the coefficient is being divided by the multiple of 10. So positive exponent means that we are multiplying by a multiple of 10, and the negative exponent means that we are dividing by a multiple of 10. So with this, let's go back to the speed of light. We said that the speed of light is 300 million meter per second, can be written as 10 exponent 8. Now with this, you have already converted your 300 million into scientific notation. So mostly anytime you are quoting speed of light, we hardly see 300 million meter per second, but I see 3 times 10 exponent 9 meter per second. So if you watch closely, you notice that we have our coefficient which falls within our range, the given range, and then we have the power of 10 which is raised to a positive power. Now being raised by a positive power indicated that it was being multiplied by a multiple of 10, which is 100 million. Now another way you can achieve this is to move the decimal point. We all know that 300 million, it assumes that there is a decimal point at the end of this number. So we move the decimal point such that we get a number that falls within the given range, 1 to 9. So remember to move your decimal point in such a way that your decimal point is now placed at a point where the coefficient is either from 1 to 9 or fall within the range 0, between 0 and 10. So here I move my decimal places 1, 2, 3, 4, 5, 6, 7, 8. And since I've moved from right to left, I'm going to get a positive power. So moving from right to left gives you a positive power, and then moving from left to right gives you a negative power. So this is another way you can achieve your scientific notation. Another way is, let's go back to the radius of the hydrogen atom. The radius is 0.00001, and as we've mentioned, this is equal to 1 over 100 million. 1 over 100 million, if we should express this, is going to be 1 over 10 exponent 8, and applying the law of indices for 1 over 10 exponent 8 gives us 10 exponent minus 8. And this, because the value here is 1, it can also stand as an answer, but then if it is more than 1, we are going to have the number appearing. So using the movement of the decimal places, we know this time round that the decimal place is at this point. So we are moving from left to right. Moving from left to right indicate that you are going to get a negative exponent or a negative power. So I move my decimal places 1, 2, 3, 4, 5, 6, 7, 8. I've moved 8 times from left to right. It means that I'm going to get a negative 8 exponent. So I'm going to get 1. Now my decimal point is here, and then I have 1. That is the coefficient. Then the power of 10 also follows. So I have 1 times 10 exponent minus 8, which is also equal to 10 exponent minus 8 because of this one. If you multiply 1 by any number, you get the same thing. That is why here we had this answer.